Good morning, good afternoon, good evening. Warm welcome to Startup School Week 4. My name is Timon Kokoschka. I'm a go-to-market manager in Google for startups, and it's absolutely a privilege to welcome you all here. Well, it's an evening here, somewhere there. It's a bright, nice morning. I'm really happy you all joined us today for our today lecture. It's an intro to RAG architectures, including Vertex AI Search, RAG Retrieval Augmented Generation. We're going to have a fantastic class today. We're going to begin in just a couple of minutes. I know for sure that many of you are here for the first time. We see this in the stats that a lot of people are joining throughout the sessions, throughout the whole course. We're halfway through. So next 2-3 minutes is just a quick reminder about our rules, housekeeping rules, and a structure of Startup School. So if you're here for the 5th, 6th, 7th time, you can take a stretch, take a glass of water, and we will start very soon. Startup School, Gen AI, we have live sessions such as this one every Tuesday and Thursday. They are available to watch on demand just after this class ends on the very same website. We also recommend a couple of code labs and notebooks for you to practice in your own free time. Think of it as a kind of a homework, but don't do them now. You can do them in your free time after the class ends. We shared over email a lot of instructions about how to access the code labs in Skills Boost platform, how to run notebooks, but every single notebook and code lab is listed here under this link, google/GenAI-labs. Housekeeping rules, please do remember to leverage the fantastic QA button below me, somewhere here. We have a lot of great AI experts that are here today to answer all your questions about the RAG architectures and Vertex AI Search. The best questions, most upvoted one, most interesting ones will be asked directly to our today's instructor. These classes, as I mentioned already, will be recorded, so you can watch them in your free time on demand. We are not sharing the slides though. Remember about the Skills Boost, you have an access at no cost. The GitHub repo that our instructor today will show is also available under all of these links. So 5 minutes in, enough of me. It's a time to invite my colleague from Google, Naresh, that will lead today's class. Ready with a great Google Cloud vest. I think we're matching today a little bit with the color, but enough of this. The floor is yours, and I'll see you in about an hour for the Q&A. Have fun with RAG.
Thank you so much, Timon, for having me. And hello and welcome everyone to this session on RAG, Retrieval Augmented Generation Architecture. And today I'm going to go through the RAG architecture in detail. A quick introduction about myself. I am Naresh Jasotani. I'm a principal technologist at Google Cloud. I'm a GenAI ambassador. I've published a couple of books, Blockchain Beyond Basics and Adopting TensorFlow for the Real World AI. I love teaching and explaining stuff. So I teach at Oakland University, Michigan. I'm Michigan-based, and I'm a YouTuber as well. So with that said, let's kick off. This is what you're going to learn today. You are going to learn what is RAG, Retrieval Augmented Generation, why it is used for, and why do we need it? What are different approaches and potential approaches? And then we're going to spend some time looking at this in action. We will see how you can use RAG out of the box, build versus buy on Vertex AI Search, as well as multi-model RAG using Gemini. Gemini, if you do not know, and I'm pretty sure that you have been following these sessions, Gemini is our latest large language model. And then we're going to talk about what next. That is how we're going to lay out the structure today. Let's kick off. So RAG, also known as Retrieval Augmented Generation. What is RAG? Why do we use it? What are the use cases that we need it? And where do we find interesting patterns, and how do we navigate and circumvent trade-off between performance as well as the right results. So let's look at it. Typical use of LLMs, right? LLMs are very good when it comes to generation, it comes to reasoning a problem, understanding a problem using prompts, but LLMs are pre-trained models on the dataset which are publicly available. For example, if you use Bard or ChatGPT or any other open source large language model, you would find that these models have been pre-trained with large publicly available data. Now, sometimes I feel that they're stuck in time. Let's give you an example. This is a real prompt. I used a prompt, what is LangChain, to a model which is widely accepted and used. And obviously, the model was trained up until a certain point in time. Now, when it came to this question, what is LangChain? LangChain, as you know, is a large language model framework which was developed and came to light and in great usage after 2021. So this model was stuck in the beginning of 2021. So it started hallucinating, means it has to give you a response because it's smart. So it said, oh, Lang chain, so I can relate it to blockchain. And what it says is that, oh, Lang chain is a fabulous blockchain-based platform. It's a decentralized platform and it can do a lot of things. And by the way, this is what you could do on blockchain. So it was able to relate LangChain to blockchain. Obviously, it was not correct. And this is what we call as hallucination. The large language models, even though they are super smart, they tend to predict the next word. It's mostly a prediction algorithm. But one of the biggest problems and challenges that we face is the data that they are trained on. These LLM models are trained up until a certain point in time with publicly available data. And then when you prompt, when you ask questions of these models, obviously they cannot go beyond what they have been trained on. And that poses problems. Think of healthcare, think of medical research. When you have terms, when you have different lingos, language that are specific to your business, and they are secret, they are company secret, you do not want to share this with somebody else. Then how do I use this great Gen AI LLM technology, but on my own data with additional new data set where I could restrict the LLMs hallucinating. That means I can restrict LLMs to answer off a particular document. That is known as grounding. So we're going to talk about all of this in a second. So what are different solutions? Imagine, let's take a use case. You have a very specific research that you're doing from a medical standpoint. And that is something that is going to change the way you operate, and it has a large leaving impact on medical procedures. I'm just taking an example. But you want to use large language models in a secrecy. That means you don't want to let public know what's going on in here. What you're going to do is, these are some of the solutions, but there are some drawbacks too. Let's talk about them. There are three different solutions that immediately comes to foray. The first is fine tuning. I'm not talking about full fine tuning here, but very adaptive layer based fine tuning, wherein you are playing with the neural net of the model itself. You are adding a layer in the front and at the back, or maybe multiple layers at the front, to ensure that the new data, your data, the model understands and be able to respond. You're basically changing the weights of the neural net. At the end of the day, large language models are machine learning models. Now, the drawbacks related to them are, once you train the model, that means you're changing or adding to the characteristics of the model. You need data preparation. Obviously, that's how you train a machine learning model. It's expensive. And you need to constantly maintain your model. Giving you an example, the technology of Gen AI and LLM is progressing at such a great speed that you have a model today. By the time you wake up tomorrow, you have a different model. So you got to keep up with the changing technologies. And when you train a model, it's in your domain, it's in your premise, and you need to retrain. So at the end of all of this, it may not work the way you would like it to work. Does it make sense? Right? So you can fine tune a model, good procedure, but when you are doing all this, you need to take care of data preparation, expensive cost related to the model training, constantly updating and retraining with data set, and at the end of the day, it still may not work. What are my different options? Do a human check. When you have a human in the loop and you are somebody human at the back end constantly checking for the output of the LLM before it goes to the user, it's a little expensive, not practical solution, and humans can tend to be inattentive sometimes, and they may have different thoughts going on, and you are trying to answer these questions. So human check may not be a feasible method here. Prompt engineering. What you could do is you can create a prompt, which could be very big sometimes, and direct the model to behave and respond in a particular way. The challenges with only prompt tuning is, and it's not just limited to the data set, but it's also limited to the technical capabilities of the model. If you have attended the previous sessions, you would know that a Gemini model or a Palm model have limitations or limits on the input tokens and the output tokens. Tokens, for your information, when you convert the text to vectors, which is embedding, we are going to talk about it, those are tokens. So there are limitations on input and output tokens. And sometimes these models are such creative in nature that it tends to hallucinate even after the right prompt. You have slower responses from the model because it has to go through all the prompt engineering that you have been doing. But at the end of the day, it's still error prone. So fine tuning, good option, but may or may not work, expensive. Humans check, not feasible. And prompt engineering, even though with a great prompt, most of the times you are going to get slower responses and sometimes the context still not correct. With all of this, how do you ensure that you respond back to your users consistently, grounded to the information that you provide, and avoid hallucinations as far as possible? That is where retrieval augmented generation, RAG, comes into the picture. Now, if I may explain RAG, it's a fancy way of saying that let's do a ranking algorithm of the context. That means when you provide the PDF or documents or text, you do a rank of the context. I'm going to give you an example in a little bit. And then from that context, you have LLM respond back to the user. I repeat, assuming that, and I'm going to give you and show you this example, assuming that you have 10K filing from Alphabet, which is a parent company of Google. Or you have huge, if you are in autos, you have huge number of pages on owner's manual talking about your cars. Assuming that you are looking at one of these PDF documents that are really big, what you do here is you are going to train or embed the data and put it in an embedding store. So you have PDFs, you chunk, and I'm going to talk to you about the architecture. You chunk this document data out of the documents and embed it and store it somewhere. Embedding is a process that converts text, images, videos to numeric numbers. The way it converts from text, videos, and images to numbers is the process we call it as embedding. These numbers are easier for machine learning algorithms, which are at the end of the day mathematical equations, can help search and look at the data in a numeric form. And when they return back to you the output, it's going to be back converted back into a textual format. So we're going to talk about that a little bit. But coming back to the use case, the retrieval augmented generation is a logic wherein you have a PDF of 500, 400, 300 pages or a document or text files. You extract the data and the text from the document. You embed it. That means you have a numeric conversion. And then you provide the context based on the question. So for example, if I want to ask, what was the net income for Google in 2022? So it's going to look for the context across different pages from the PDF or the text documents, and it's going to rank them up based on the context, and it's going to give that context to the LLM. The LLM then look at the generation, which is on the right side, understand the results, and going to respond back to the user in more of a natural language. The reason you want to use RAG, which is retrieval augmented generator, the topmost reason is grounding. You want to ensure that the model does not hallucinate. It reports back the fact which is coming in from a document which is the source of truth for you. Number two, LLMs may not know the business proprietary language. In the case of medical equipments or medical research, the LLMs might not have seen that data in the past. You're providing that data to the retriever, which is a ranking algorithm. We are going to talk about it. And at the end of the day, you want to have consistent response from these models, less hallucination, and grounded information. That is where retrieval augmented generations come into picture. Now think about this. And I want you to imagine. Let's talk about automotives. Because I'm Detroit based, Motor City, let's talk about autos. You are driving a car and you are asking the car, hey, what's wrong with this? Because there is a check engine light or some kind of a error out. And then the car says, oh, you know what? Check engine light, don't worry, it happens, ignore. And you go for a mile, mile and a half, and the car breaks down. Who is responsible for that? Is the car company? Is it the system, the software system that has been installed? Or the model itself, which is hallucinating? You cannot have a model stand in court of law. And therefore, you need to ensure you, as an owner of the auto company, needs to ensure that the response from the large language models, generative AI, is grounded to the fact. They are not hallucinating. They are not looking at their publicly available information and responding back. They have certain facts that are grounded to. I guess we beat enough on this one. You need to ensure that you have right level of grounding before you can do any responses back to your users. So let's look at it. The RAG, retrieval augmented generation, a typical prompt looks like this. If you are looking at the first section, these are prompt engineering statements. You are an intelligent assistant helping the users with their questions, strictly only follow the pieces from the context, think step by step, and do not try to make. So these are some guardrails that you have put from the prompt perspective. And then you have context. This context can be retrieved using ranking algorithms. Some of the ranking algorithms are cosine, very famous, similarity search. In Google, we have vector search, which is based on proprietary algorithm known as ANN, approximate nearest neighbor. So imagine you have 300 pages and you're looking for net income that occurs in 15 pages. What you're going to do is you're going to have ranking algorithm wherein you're going to rank those 15 pages somewhere in the document to come first, and then you have the remainder. And then you are going to provide the top 15 pages. there is a there is a parameter. You can choose what number of top context you want to provide back to LLMs. Assuming you have top 15, all the 15 contextual data set is going to be provided to LLM. That is your context. The question was, what is the net income or net revenue of Alphabet? So that's the question. So based on the context, this is the question, provide an answer. That's the whole concept of retrieval augmented generation. As I said, let's look at some common use cases and applications. Question answering, Q&As, semantic search, summarization. You want to find out what is the focus of Alphabet on sustainability. So based on the transcript, which happens normally after the quarterly reports, where Sundar and other people from Alphabet, they go in front of the people, they take questions, and you can take those text, transcribe it, and do a summarization on it. Or you can look at investor relations website, which we're going to look at in our demos, get the quarterly reports and understand and summarize based on sustainability or what is Gen AI doing, how the leaders, Alphabet leaders and decision makers are looking at Gen AI overall from the market perspective. You can summarize the entire document or part of the document. So that is one of the use cases. Q&A. I talked about automotives, wherein you can ask questions. What's wrong with my car? Where do I go fix this? Or something like a chatbot, wherein you are interacting with a bank, a representative, saying that I don't know why this transaction is showing up on my credit card or debit card. You can have the chatbots respond back to you in a more natural language. And then you have agents. And this is where it comes to the art of possible of Gen AI. I was talking to somebody earlier today, and I was telling them that remember the worlds of internet back in 1998, 1995, late 90s. It was all the art of possible. What else could you do? But back in 1998, 1999, if you would have gone and told somebody that you can order food, order car, and order anything online without having to step out of your home, would you believe it? You would have everybody literally in a pandemic working from home, obviously more technical and people on laptops, but you could still continue to work from home, meet with your people online on cameras, and still continue the work. Nobody would have believed it in the 90s, but today it's a reality. That's where, looking forward now, you got this Gen AI boom. Think about automation. Think about how you can have, so Gen AI is wide. How can you bring Gen AI to do some specific automation task? We call it as agents. There could be some very interesting use cases wherein it looks into your database. You can ask a natural language question, and obviously with a little bit of metadata management and prompt engineering, you can ask a question in natural language. It understands the question, converts into an SQL, which is no longer difficult. And then the SQL runs against the database, gets you the data in a graph, and shows you on a dashboard. So you went from a natural language query to metadata, SQL, data retrieval, and plotting the data in a bar chart, column chart, pie charts. So you went from natural language to pie chart from a user experience. Think about that. Another way to think big, art of possible, is you could have your insurance. Like everybody of us may have car insurances, health insurances, different types of home insurances and stuff. But There are so many fine prints that we worry about them when something happens. Otherwise, we just pay, we sign the document, and off we go. At least I do. There are a lot of other people who read the fine prints too. But then imagine all of these documents are sucked in somewhere. Obviously, it's private to you, so you don't want to have it in the open source domain. You need to have it in a private domain. And you are able to use RAG to ask questions of the insurances that you have taken and the benefits that you could potentially get, and ask questions of it. These are some very common use cases that RAG and LLMs kind of pertain. I'll be more than happy to answer questions at the end of the session or during the later part of the sessions. Please ask questions not just related to RAG, but feel free to be even wider. Moving on. This is the question that you, as a developer, as a scientist, as a coder, you always ask yourself, when do I use one versus other? Because this is very new. I don't want people to come back at me and say, hey, you did the wrong thing. When do I use what? In cases where you have external knowledge required, that means potentially my insurance, which is very specific, personalized to me, may not be available on the internet. And therefore, the model would definitely not know what is in the insurance. So in that case, I'm going to use RAG. When you are wanting to avoid hallucinations and have grounding, that means all your answers should have a source of truth, which are your documents. You need RAG. When the data is constantly changing, you have insurance on 1 year, your insurance could change after 6 months. And when you want to respond back in your own language, like for example, medical or autos, the large language model may not be good at, because you could have a specific type of vehicle model that could have different signals, different types of working at the back end to provide you oil filter or any other warning signs. You need to ground your vehicle interaction to the vehicle's owner's manual, which is unique for that combination. There, you would use RAG. When you would use fine tuning, you would use it in cases wherein you need the model itself to change. So, model adaptation, we call it as adapter layer. When the training data is available, you are able to get the feedback from the users, and you are able to retrain the model based on that training data. When you do not want the model itself to have the public information, the model needs to be in your control. If that is the requirement, then yes, behind a firewall. Sometimes these models go back to a Google frozen model, that's for later, and they get the information from there. When you fine tune a model, the model resides in your domain. It's your model. So if you want to have that level of control, absolutely yes. So that's where you would use fine tune versus RAG. There are some benefits of RAG as well. I think we have covered most of it. Factuality, grounded to source of truth. Better context, context coming in from your data. The data is updated because you can update and have newer data train on the model, start embeddings. And then it's cheaper as compared to fine tuning, because there you are maintaining a model, you're serving the model. Here you have embeddings data, and you are consuming that embeddings data from the model that is already trained. And governance, that's very important. Imagine you could personalize the response from a model, and we are going to see how. You're going to personalize the response from a model for a specific user. Access control. You don't want to give access to the HR data to a manufacturing person, or a person in the manufacturing domain. So you could have guardrails, blocks, access control mechanism, and entitlements across domains. Now, RAG, is it perfect? Oh my gosh, I got the golden uh, thing to fix all the problems with hallucination. Not really. Reason? First of all, you would need a tool to measure what the response type is. For example, uh, when you do the retrieval, the top context and the bottom context are used more often. But if your most important context, because of a faulty or not so great ranking algorithm, is somewhere in between. So, for example, if you have 15 different contexts, net income appearing in 15 different pages, and you have the top four and the bottom four with not so great information because of your ranking algorithm, but the middle section has the real net revenue, you're going to miss out on that. So the way how you retrieve the information, the context, and provide it to LLM has a large impact on the RAG precision. Now, precision recall. Those who are familiar with machine learning language, remember confusion matrix. You have precision and recall. The same thing can happen if the content or the output is right versus incomplete versus wrong. So let's look at low precision, when not all chunks of context are retrieved properly. Total recall, not all relevant contexts that are retrieved or all context chunks that are retrieved are relevant. You see what I'm saying, right? And at the end of the day, these are quality related, but operational overhead. You got to maintain embeddings, you got to maintain data pipelines, data redundancy. Latency could increase if the context is huge. And at the end of the day, you need a team of software developers and machine learning engineers to maintain all of this for you. So again, there are certain challenges, but it's a trade-off between fine tuning versus RAG. Embeddings. I think we discussed a lot of embeddings at a very primitive way. Embeddings is a method of converting a data, a multimedia data, a text data, to numeric vectors. The reason you want to use numeric vectors because the machine learning algorithm is a mathematical equation. And at the end of the day, in order to find similarities, like in this case, in order to find the closest nearest neighbors, the match, you would use numbers. So embeddings is a very important process in the entire chain. Now let's look at it. How do I create a RAG system? Assuming you have PDFs, Word documents, video files, images, different sources of data. You cannot consume all of the data, all of the 400 pages in the owner's manual of my Tesla or any other car. I cannot consume all 400 pages at once. What you do, you chunk. You can chunk by number of tokens. That means the number of embedding parameters or number of embedding output. So you have tokens. You can chunk it by page. You can chunk it different ways. But each chunk may necessarily have same amount of data, except for the last one, obviously, because it might not be, it might not be even odd, right? So you have chunks of data coming out of PDF, and you store those chunks in an embedded format in a database known as vector database. The name vector is the name of, the name vector is derived because the way you have embeddings, it's a vector representation of the PDF. And the database that stores vector is a vector database. Common databases for vector are LOIDB, which is on Google. You have ChromaDB. You have other open source databases that can store vector information for you. Now, how do I retrieve that? When you have a vector database, you ask a question. You embed questions too. So now you have the source, which is pre-embedded, And the question that I ask, for example, net revenue, I'm going to embed net revenue as well. And then I would do a top K match, the most similar pattern, contextual match. And when I retrieve the chunks here, I provide that chunk to LLM to respond back to the user. So I repeat, from the documents, pre-processed chunks stored in a database in an embedded format, embeddings, numerics. And when you ask a question, convert that question into a number, an embedding, and then give those chunks to LLM. How do you do it in technology wise? When you have document known as corpus, you have Vertex AI embeddings. I'm going to talk to you about a code wherein we are going to use text embeddings from Vertex AI. Then you can store the key value pair. Embeddings are basically key value pair uh, on the Vertex AI database, and using those embeddings, you are able to then use the user prompt, which is the question, embed the question as well, and search the nearest match from the embedding store. So we are going to use Vertex AI. People who do not know Vertex AI, it's a one-stop shop for all AI ML things on Google Cloud. So I'm going to show you in a little bit. And then based on the context, the LLMs like Palm or Gemini now, which is the latest version of the large language model at Google, they would respond back to the user in a more natural language. So I hope this understands. I mean, you understand this concept. You have corpus, chunk, embed. And once you have the vector store, which is embedded, you would use the prompt embedded, do a ranking algorithm search, get the context, and ask LLM to respond back to the user. So retrieve, that means retrieve it from the embedding database, augment it with your prompt saying that do this, don't do this. Remember the prompt that we talked about? And generate, have LLM generate the response back to the user. So retrieve, augment, generate. That's why RAG. Now, so better retrieval is equal to better results. Assuming that you did everything that you could potentially do, but your answer, your output is not great. The reason for this is the ranking algorithm most of the times. It can be on anywhere during the process, but it could be a ranking algorithm. How do you retrieve the context which is more relevant to the question? So for example, if I say, what is the net revenue from Google or Alphabet? But you're defining what is a net revenue. That wasn't my question. I know what is net revenue, but I want to find out the net revenue for Google in the last quarter. You see where I'm going with it. So let's talk about it. Again, the same thing, load your data, chunk your data. So load and break it into pieces, embed those pieces and store it in a vector store. And then you use a ranking algorithm, cosine, vector search, which is ANN, or approximate nearest neighbor. And then you can apply some user profile. Remember access control? Based on the user personas, based on the department, based on various different things, you can apply the filter in the prompt, which is augmented. And then you provide that context to the LLM and generate an answer. Please understand that if you do not have the right level of embeddings, you might not get the right response. If you do not have the right, if you have the right embeddings, but you do not have the right ranking algorithm, that means it's listing non-relevant or less relevant information at the top, then you might not have the right answers as well. So it's a very minute art game which you have to do. But it's Google, right? When you talk about Google Cloud Platform, and you are a startup, I don't have time to do all of this. This is where you do two things, build versus buy. Sorry. This is where the most important decision, do I build it buys it or do I buy it? The top one would look very similar to what we have been discussing. Get your data, parse it, that means consume it, chunk it, put embeddings like embed it, store the embeddings, and then search the context and have LLM respond back. This is what we have been discussing RAG. Google, which understands the user's pattern and how to have very low level, very no code, low code platform level things made available to the users. That is where Vertex AI Search comes into picture. Vertex AI Search says that give me your documents and I'm going to do the entire thing. So if you look at the parsing, chunking, embedding, indexing, search, all of this, I'm going to do it in a box, out of the box. But I'll give you that option wherein you can bring in your own document parser, you can bring in your embeddings, you can have your own ranking model, as well as you can do the quality search adapters. You can customize it the way you would like. But we will take care out of the box, parsing, chunking, embedding. And think about that. If you're a startup, you're running low on human power, labor resources, wherein you have engineers that can go do better things. And what you're going to see in the demo in a second is I'm not only going to create a RAG for you out of the box, but have it integrated with your web app. So imagine you're a startup and you're a startup on, I'm just making it up, um, WebMD, like WebMD chat, right? And if you are the startup, you are helping customers to ask questions, obviously with some grounded facts and information. Assuming you are focused on COVID or flu or very, non-trivial things. Of course, COVID is trivial, but taking the context from cancer and other things, these are non-trivial things. Now you are able to create a website, your developers create a website, you have documents of COVID from different countries, you have procedures and steps. What you could potentially do now is you could have Vertex AI Search build the RAG search for you. And as soon as you have the RAG search, you can integrate it with your website and off you go. You can have a chat, you can have anything and everything that you're looking at, bringing it, building it on your own. So that is a build versus buy decision. I'm going to show you both. I'm going to show you out of the box as well as the codified format. Now, let's see it in action. What you're going to see again, Vertex AI Search and multi-model RAG using Gemini on a notebook. With that said, let's get started. So give me 1 second. Okay, so what you're going to do is you will have access to Google Cloud Console. If you have attended the previous sessions, you might be knowing how to get access to Google Cloud Console, how to get some credits and things like that. On the Google Cloud Console, you're going to say search and conversation. This is the buy. That means this is out of the box thing already available. You would come here and you would see the apps. You would click on new apps. Now, I'm assuming that we are doing a search or a chat. You can also do chat, you can do recommendation. This is a new thing, generative agent. For now, let's keep it search. Now, I'm going to show you some of the samples, like Google 10K samples, how it looks like. These are available on investor relations website. I can download those and put it in a Google Cloud Storage bucket. Here is how you can create a bucket and put all of the documents from the investor relations website on Google Cloud. You have the 10Qs, the 10Ks, and the quarterly results from Google Alphabet, which is the parent company of Google. So I put all of this here and I come to this create app and I provide the app name. I'm going to say demo Feb 6th, and I'm going to provide a company name. I'm going to say Google, and I'm going to keep global for now, and I say continue. Now, it's going to ask me to create a new data source. And if you look at it, these are my options that I have to create the data source. I can have website URL. So for example, I cannot go and read all the data from google.com or cloud.google.com. I cannot do that because the website needs to be your website. There has to be some A record or something that you need to do to validate that this is your website. And you can have list of websites, URLs listed over here. You can also have different links, and you can do a while characters in front or at the back to exclude few websites as well. So website and different URLs can option number one. You can have structured data from BigQuery as well. You can have APIs. In this case, we are using cloud storage. So you're going to select the cloud storage link, the path. You can have unstructured documents, JSON, new line files, structured, unstructured, various kinds of documents. At the end of the day, you can browse the Google Cloud Storage where you have your document, these documents. Now, once you do this, say continue and import. It's going to take some time, let's say 10 to 12 minutes. So I already got it created for you. Once you have the data imported, that means embeddings at the backend, the data ingestion done, you can now preview. Let's ask the question, who is Sundar Pichai? And look at that. It says Sundar Pichai is the CEO of Google Cloud and Alphabet, Google and Alphabet, and he has served CEO of Google since 2015. And where did this get the LLM get the information from? Number 3. So look at that. Sundar Pichai, CEO of Google and Alphabet. Sorry. So if you look at it, these informations, the output, the responses are grounded. That means they're attached to reality. Now let me ask this. What is the EPS? I think what is the earning per share of EPS of Alphabet in quarter 2 of 2022? Look at that. The diluted EPS of Alphabet in Q2 2022 was $1.36. And look at now citation 4. If I click on it, I can open it, and it goes and takes me to where the answer came from. Look at that. The answer came from here. So number 4, the Google exhibit here is where it got the information from. Now, if I want to integrate this widget, I go to integrations, and it provides me an option to integrate as a widget. That means the entire search bar can be embedded on my website, web application. Or I can continue to do an API call on this one. So this is how you can do an API call as well. In the configuration section, you can fine tune it. So you can search with an answer, with a list of results, or search with follow-ups. If I click on search with follow-ups, you can ask follow-up questions on it as well. How many results count do you want? The top results, 5 or more. You can obviously change it. And then how do you want the content to be responded back? Do you want autocomplete, autocorrect? And then you can customize the summary. This is where you can do prompt instruction. Remember the prompt tuning? You can replace with a template. You can say non-technical, and it gives you instructions. These are templates. You can go in and modify it. And once you make the changes, say save and publish, and you can preview the changes here in the web as well as mobile format. Now, with that said, what we're going to do is this was build versus buy thing. If this is buy, this is out of the box, low code, no code platform where you go and provide the data. And once you have the data uploaded, you can do the preview. And from the preview, you can ask questions. Once you are good with the configurations, you can start integration, and then you can analyze the responses as well. So this was buy. That means you have the search and conversations, low code, no code stuff. Now let's do a quick recap before we go to the code. What we have learned today is there is a RAG application, retrieval augmented generation, wherein you can consume data, your specific data, your company specific data, business proprietary data, and then have the model look at the context and respond back to you. Number one. Number two is there are different potential options to do this. You can have buy, that means there is a service that Google offers, search and conversation. And looking at that, you can just upload the documents, it will do its job. You can do some configurations and integrate with your applications. Now, what if I want to build it myself? Number one. Number two is what is the pricing? Right? This is not a sales call. Please understand, I'm a technical person. But in the previous one of the sessions, somebody asked me pricing. So I want to make sure that I bring up the pricing. This is the Vertex AI Search pricing. For 1,000 queries, you will have $2 per query per 1,000 queries. And for standard search, enterprise search, there are different data indexing options. There are different pricing for conversation. There are some credits. You can go read this document. So from a pricing standpoint, it exists out there. Now, let's wear the technical hat on. And let me show you how you can get started to build your custom. So what you could do is, this is the Git repo, and I'm going to share that Git repo with you. There are a lot of code patterns available. So generative AI Gemini, under this you have use cases, and then you have retrieval augmented generation. So this is the RAG that you are trying to look at. Again, this is an open Git. Go ahead. Please understand that this is only for sample for you to get started quickly, but you need to put your own guardrails, your own data. This is a starter kit, but you got to make sure that you know what you are doing, right? Otherwise, it's your responsibility. So let's look at that. So what I'm going to do is I'm going to show you a notebook. If you are not familiar with notebooks, it's a JupyterLab notebook. The thing that you're looking at is Colab. Colab is a free product from Google. You could use this, or remember Vertex. We have been talking about Vertex. So go back to the Google Cloud Console, search on Vertex. This Vertex AI is one-stop shop for all AI ML things. And then you have Vertex AI. You can see Model Garden, wherein you see all different types of models. Gemini Pro, Provision, Claude, which is Google's. Gemini is Google's. Claude is not Google's. Claude is Anthropic. You have Llama from Meta. You can have different models brought in. And here you can create a Colab notebook within the Google Cloud. You could do that as well. Or you can have a JupyterLab notebook spun up in Workbench. You could do that as well. So there are different methods and ways to do it, but I like Colab. If you have used Colab, it's a great product. If you have not, let me show you how you could. So go to Google, search for Colab, and you have this Google Colab thing shows up, and you can create a new notebook and start with it. So that's how so simple it is to get into Colab. So Colab opens up, it's a Jupyter Lab kind of a notebook, and you can start writing code. Now, remember the Git that I showed you? Sorry, I probably lost my screen sharing. So remember the notebook that I showed you. If you open the notebook, you can open the notebook in Colab as well. So there are different methods to open Colab notebook. Now, I'm not gonna run this notebook in front of you because it's gonna take a lot of time, but I'm gonna explain how you can build a multimodal RAG using Vertex. Now, what we're gonna be using here is this. We are gonna use not this one, sorry. We are gonna use the Google 10K sample. I'm gonna have this 10K published by Google, and we will ask questions of the data from this particular document. There might be publicly available information that you can go search on 401ks and different stuff. But at the end of the day, we would like to search based on the grounded single source of information, the source of truth for that model to be able to respond back. This is our goal. So we are going to use and consume this PDF file, which is the Google 10K sample, use Gemini multimodal and run it. So I go in here. This notebook has so much details and step-by-step explanation of what we are doing here. So please go ensure that you read it. It's amazingly simple if you understand the concept. At the end of the day, what you're going to do is extract and store documents with both text and images. Multimodal. Multimodal means ability to consume text, images, videos, pictures, obviously images, videos, YouTube videos, and stuff like that, right? So we are going to only look at the PDF, which has text and images, but you can do a lot more. Now, obviously, you can look at the Vertex AI pricing, how much you're going to pay for it if you have to do it on GCP Cloud, and then you have pricing calculator here as well. Now, let's get a little bit of space here. The first step is to install SDKs. You need an upgraded version of Google Cloud Platform, and this is Python for PDF, so you need to install this. Once you install this, you need to restart the runtime. And I have ran this before, so you can see the output here. So install the packages, restart it. Now, because I am doing it on Colab, you need to authenticate the user. This user authentication means that you are able to connect using my account onto this particular Google Cloud project. Remember, for anything and everything that you do on the Google Cloud, you need to be connected to a project. So I'm connected to a project known as Cloud LLM Preview 1. All right. Now, once I authenticate, this is where you would do the project ID and location. I'm in the US, you can select a different location, but I believe that LLMs are only available in certain locations, not all locations. So probably a little Google search will help you. Next, initialize the collab. So these are all set up. I got the documents, I got the the libraries installed, I got it reset, restart, as well as I set up the project or authentication. So now this collab is ready to run multi-model RAG. Now, Vertex AI has generative models. You can import these models, content, generate config, response, model, image, and part from the Vertex AI generative models. And the Vertex AI language models has text embedding. The text embedding can do embeddings of the text, and multi-model embeddings can do embeddings of text as well as pictures. Now, I'm going to use the Gemini Pro Vision model. The Gemini Pro Vision model, how do you access it? A quick show and tell. I go in here, and this is Vertex AI on cloud. I click on multi-model here, and this is my Gemini Pro model right here. So these are examples, and this is how you can access Gemini Pro model, Pro Vision model from the Google Cloud. So I'm going to use this model to do the multi-model RAG. And then you have text embedding model, and I'm going to use text embedding gecko model for embeddings, right? Okay. Next, in the GitHub, we have utils. So if I go back to GitHub, and I think we can go to this GitHub link, and then under RAG, we had utils. So this is a utility file that you may want to import. You definitely would like to import, all right? So I imported the multi-model RAG utils. And once you import it, you would see that the utils is here. So I imported this. Next, download the documents. When I do the download documents, I get the sample file, which I showed you over here. This is the file that I get, as well as I get some pictures against which I can compare. So double clicking on picture, in one of my use cases and show and tell, we are going to compare different pictures. So we are going to come back and look at the pictures at that point in time. Now you have building metadata of documents. Now here is where you're going to use the RAG util. So you're going to import the util, and you're going to say get document metadata. Please understand that it is very important for you to chunk it and understand what's text and what's images. So using the Google 10K samples 14 pages PDF, you are writing a prompt. Explain what is going on in the image. If it's a table, extract all elements of the table. If it's a graph, explain the findings in the graph. Do not include any numbers that are not mentioned in the image. In here, the get document metadata function, which is in the utils, returns back two things: the text metadata and the image metadata. So once you process this, all the images, it's going to be saved in this format, and all the text you're going to see in this format. So let's look at text metadata. You have text embeddings. This is how embeddings look like. So file name grounded, remember grounded. So this embeddings is coming from page number 1 of the file, and this is the chunk number, and this is the chunk text, and this is the text embeddings. So please understand that all the information, remember the diagram, the RAG diagram, everything is grounded. Next on the list is images. In here, you have image description, embeddings from image, and text embedding from image descriptions. So when you have image metadata, it shows you where, again, grounding, citation, knowing the facts being consistent is the property and functionality of RAG. You are grounded, you know where it's coming from, what page number, what image number, what's my image description, what's my embedding, and this is how a text and multi-model, which is image, embeddings look like. It's basically vector. A vector representation, as I mentioned, is an embedding of data. Make sense? Perfect. Let's move on. Now, we are going to use these helper functions. Again, all of these functions are in the util. So it may not be a bad idea if you're a developer to go into the util and look at different things that you have it in here. So this is a util py and get text embeddings. You can go in and look at it, right? How it works, how it responds. Please feel free, all right? So from the RAG utils, we are going to get these 5 things or these 5 functions. Get similar text from query, explainable. Given a text, find the document which are relevant using cosine similarity. Remember the ranking algorithms? Here they are using cosine. Next, text to text citation. How do you know that the response that is shown to you is coming from which location? Grounded to reality, grounded to your source of truth. Get similar image. So this is an image finding. Given an image of this, for example, find an image which is very representative of this, or find an image which looks like this. We're going to do this, and therefore you have a function, get similar image from query, and then print text to image, citation, you know where it is, and get the responses from the model, which is G piece of RAG generation. And all of this we are trying to get from the intro model RAG utils. Now let's do a search. The question is, I need details for basic and diluted net income. Remember net income per share of class A, B, C share for Google. And I'm going to run this, get similar text, the project ID, the query, this is the query. It's going to embed the query as well. It's a text question, so it's text metadata, text embedding chunk. I need only the top N, the top 3 context, and then embedding size is 1400. You can have a different size as well. And look at that. It gave me relevancy based. This is a score from page number 1, chunk number 2, because many of the shares is class we are held by brokers. And then you have 64 record holders. So it tells you how many class A, class B, class C, net income per share. It doesn't respond back. Why? Because net income per share is available in the images and not in the text. Challenges, right? If you are trying to do embeddings and it does not get the right context, the LLM cannot respond back to you. So the reason why we wanted to show you this is because if you use only text, it's not going to respond back because the shares of type A and type B or class A, class B are, this is a picture and not a text. This is a text, but this is a picture, an image. So let's do an image search. So we are going to search similar images with text query. The query remains the same, but we are now going to use both text metadata and image metadata. And when I'm going to, oops, I shouldn't have run that. Sorry. It's not going to respond back, but here it would have responded back for, yeah. So sorry about that. This is not correct, but it's going to respond back to you on class A, class B, and class C. I shouldn't have done that, but it is what it is. Now, you can also do text to citation. So if you look at this one, it tells you the text of class A, B, and C, and tells you how many stocks, citations, where it came from, the page number, the image. If you look at 9033 image, that means page number 9 or page number 10 and 33rd image, you will find the class A, B, and C output. Image description, look at that, class A, class B, class C. Let's look at page number 10. How about that? So I go in here, I scroll down to page number 10, and it says class A, class B, class C. I shouldn't have run that cell, otherwise you would have gotten this table over there. Anyhow, next time I'll be more careful. Okay, next is image search. You can search the document with the image query itself. So tag table revenue, find all the instances where you find an image similar to this. Year ended December 31st, 2020, 2021, how it's going to find something which looks similar to this. And when I run it, it is going to respond back. Look at that, year ended 31st, 2020, 2021, and look at this. Other cost of revenues and total cost of revenues. You have cost of revenues here. Therefore, it's trying to match the image from the document or from the search to the embeddings. And it is using both a combination of text and the text metadata. Please understand that it's all embeddings and the context that is driving RAG. Next, you can do the citations as well. I'm just going to skip forward. You can match different images together as well. Now, let's look at reasoning. We have a class A share, and this is the graph. What we want to find out is, similar to this, find out all the images. And I gave you this input to the model. And the question is, how has NASDAQ performed with respect, this is class A, find the class B and give me the comparison of NASDAQ on class A and class B. And when I run this, it gives me the text output as well as it shows me this is class C as well. Remember class A, B, and C. So it shows me the text. Here, the input is class A. This image is class A image, but it also gets class C and B images as well. And finally, this is for you to perform. Get all the relevant chunks of the question, how has NASDAQ and S&P performed for class A and class C shares? And would you buy class A or class B? Which one would be better to buy and why? So it provides reasoning as well. And then find all relevant images. You can get the text as well as pass the context to Gemini and let Gemini respond as well. So please understand that once you have the basic chunking and embedding done with images as well as text using multi-model embeddings, you are able to figure out the images as well as the text, and you can do a Q&A based on that as well. So with that said, we are almost at the end of our session. I'm going to have what's next, what we have covered. So we are very close to our few slides. So in summary, this is the process that you need to remember, how you want to be involved, which embeddings to use, multi-model, text embeddings, where do I store, how do I retrieve. Sometimes these vector store need to be high memory, in-memory databases, because you need faster retrieval of vectors. And again, if you want to know more, you can go to this GitHub repo and get use cases, retrieval augmented generation. This is YouTube videos, as well as you have Skill Boost to understand how to use Vertex AI Search, the buy application. Again, doing a quick recap, what we learned is RAG, retrieval augmented generation. What we also learned was we were having a lot of embeddings, chunking, chunk embed, then store, and then query embedding, find the right context and respond, or let LLM respond back to the user. So with that said, I'm going to turn it over to time.
Thank you very much. Thanks. I'll leave you a couple of minutes for you to take a stretch, take a glass of water, and get prepared for the questions and answers. Naresh said that one good thing that you have access to Skills Boost, and where you can practice all of this using our labs over there, or you can use also the notebooks that we covered today. But if you're ready to build Gen AI solutions, I will once again, yes, for all of those that are joining us for every session, you know this slide very well. But I'm just super happy that at Google we have a Google for Startups Cloud program. It gives your startup, whether it's a bootstrap startup, VC-backed startup, whether it's AI first startup or Web3 startup, we have offer for everyone. So scan the QR code, go to Google/Cloud-program to learn more about our program. These programs give you cloud credits, first and the foremost, in different values from $2,000 to $100,000, even $250,000 to spend on a Google Cloud platform so that you can build right away with us. There is also additional benefits, access to experts, trainings, Skills Boost, workspace, credits for maps, access to a community, startup success manager. So a lot of benefits. So if you're still thinking, well, I just saw a couple of cool features, I want to try them, this is the right moment to join the program. So all of these details, Cloud-program available for you. And with that, I'm gonna invite Naresh back to me so that we can have a quick chat about RAG. I definitely prefer RAG instead of saying all the hard words, retrieval, augmented generation. That's kind of a hard. But you have covered today a lot, and I would say you are kind of recommending to use it and many specific use cases. But I will start with this question. There are a lot of big companies that have invested talent and money to build great models. They are tuned, they are ready to use. Why someone and a startup should consider investing time, effort, money, and talent in RAG, and who should just stay with a ready-to-go out-of-the-box solution? So what is the threshold, maybe? What is the question that one should ask to themselves? And if they are deciding on RAG, what will be the first step from your perspective?
So I am a firm believer of something that startup needs to be very careful about. By the way, I help a lot of startups in understanding and finding out what is the right pick and what is the right decisions for them. I'll give you an example. And I mentioned it earlier as well. The most important piece that startups would need to secure and be very diligent about is the human effort, the human labor. So if you are a startup with funding, obviously it's limited, it's not as vast as some other big companies, so you need to save the most expensive asset for you. If it is humans, absolutely use by Vertex AI Search. The reason it's going to be fast, you could build it faster and then have somebody else take care of the models, the RAG, the embeddings, and all of this. You might be paying a little more, but you would imagine, you would think that you're going to save a lot at the back end. Number one. Number two is, if you are a company with resource intensive and you don't have dollars to spend, then you could look for developers to build it custom for you. And number three is, if you are a startup company, the number one thing that you want to make sure that when you are interacting with your customers, every single time you are able to provide consistent, grounded, and factual information. And that is when you want to use RAG. I hope that answers.
Yeah, thank you so much. I'm browsing through the question. My helpful elves just gave me a couple of those that were repeating or were upvoted. And there were a lot of questions about vector databases. You've mentioned that the vector databases are important here as a way to introduce data. So the question coming from Srikant Gedela is, are there any cost-effective alternatives to Vex?
Yes, absolutely. And the most cost effective could be free, right? So
Yes.
you could get some open source databases like ChromaDB. You can have these databases can be as simple as a Google Cloud Storage. When you do Vertex AI search, it stores in Google. One of the options that you can use is store it in Google Cloud Storage, which is very cheap. But when you are retrieving that information, obviously you need to pay the query cost. ChromaDB, you can have in memory. You can store the ChromaDB as an output file, but these are really low cost thing. If I were you, and of course, storage and retrieval is a very important thing, but I would be thinking mostly from the ranking function. The ranking functions can tend to be more expensive because now you are searching, you want to find the right context, you are using LLM. Storage is cheap as compared to retrieval and compute.
Yes, and this storage was a king back in the days, 10, 15 years ago. That was the biggest cost to many companies, to store the data using hard drives, like physical ones. Then the whole revolution of cloud started. Okay, thank you for this one, and I agree. The cost effective is free. The second question is going to be a long one, so please focus. Is from Volodymyr Prokopiev. What about if all 500 pages have useful information and answer should be based on them? For example, each page has some value, number of likes. And my question is something like, what is average number of likes or topics have the most number of comments? Just take only 15 from all 500 as a context would not help. So what to do in this case? Use all 500 as a context is not possible because it would be more than input limits for model.
Absolutely, great question. And whoever asked it, I understand where you're going with it. So let's take a step back and ask a question to ourselves that do we want to use fine tuning or RAG? This particular thing could be a fine tuning thing because now you are changing the model, right? Because it seems that you have information scattered in all of the pages, 500 pages, for example, that you have, and you are going to fine tune the models. Tuning could be one option. But again, as we mentioned, fine tuning may not give you the right answer all the time. Now let's talk about RAG. When you have an information like this, what you're doing, it doesn't have to be a page-wise chunk. You can chunk within page itself. So you can have 10 chunks per page. Now you have 5,000 chunks. Now, when it tries to retrieve, please understand that the model also has a limit on the token that you can input, the context that you can input. So now you have chunks, smaller chunks, and it might be inputting, let's say, out of 5,000, let's say 500 chunks. If it does not match or if it overflows the token limit, it's not going to give you the right answer, number one. Number two is LLMs have the capability to list the top 10 and say much more. So now you can list the top 10 likes, for example. And if you go even detailed, if you have information on every page, you may want to filter down the information. So now you can ask a user to say, hey, do you want to, this is a broad question and this is what I found. Do you want to have a very specific question to ask? Maybe you can reframe your question or tell me what you're looking at, right? So there are different ways to deal around with this and think about that. This is technology. What you're trying to solve for has different method. There are different options that you can do.
Great. We're talking about 500. The next question has a number 7,000, and it comes from Eric. Eric is asking, if I have a registry of multiple objects, like 7,000, that will be dynamically updated, and I want to ask detailed questions on a single object, but also want to be able to ask an analytical question on multiple objects with high fidelity, for example, annual financial reports, to understand future trends, developments. Is this all possible with a single RAG model. So asking detailed questions on a single object, but at the same time, analytical future trends about multiple objects. Is single RAG model able to help with that?
So great question, by the way. And I'm going to bring my slide up. If you can pull this slide that I'm sharing right now. So let's look at what it's going to be single and what could be multiple. The RAG is the entire thing, what you're seeing on the screen, right? So now the PDF, you have 7,000 and constantly updating. So you have one source of data. That means assuming PDF for now, and then you have chunks. The vector database will have the 7,000 or whatever the number that you have. That's going to be one. The retrieval logic is going to be one ranking algorithm, cosine, ANN, and or others. The number of chunks that are retrieved would be based on the question that you ask. And then based on the question, you could prompt tune the LLM to respond in one form or the other. So at the end of the day, the pre-processing, which is the top part of the thing, and the retrieval might be one. Augmentation and generation could be multiple, right? So it's a complicated logic, and we can definitely talk on what you're trying to achieve. But at the end of the day, embeddings, retrievals are going to be one. Prompts could be different based on the question that you get.
Thank you, and I hope it also answers the question for Eric. I know all our AI experts were trying as much as possible to answer all the other questions during your session. I have one more at the end related to cost efficiency, because there is a lot of concern about that, and with the current economic situation, especially startups should look very closely to each dollar they spend here and there. So the question would be, wouldn't it be just easier? Because right now the contexts are getting larger and you can put a lot of things into the context. So why wouldn't I just put everything, all my docs, all my copy paste, and put everything I need to a context and just use this LLM to retrieve data directly from what I'm pasting over there? Would it be cost effective? What are the limitations? What's your point on that?
So, first of all, let's talk about the right thing. If you have everything that you put in, you might go out of tokens because you have the token limit on different models, right? Number one. Number two is the questions that you're wanting to ask. And if you have to read the entire book again and again for a question, that slows down the process. So it's a book, right? So the LLM reads the book and indexes it. You're not using the indexes and say, don't worry about the index, go read the book again. Of course, it's going to be fast, but it's going to be not as fast as you would expect it to be. And number three is from a cost efficiency, not just from a dollar value of the APIs, but a time wait. Like if you are asking a customer to wait, the customer experience is also I may be thrown out of this room, but no, I don't want to join this call. Sorry. So if you think from a different perspective, it's the cost of customer experience being worse, and in order to get back the customer confidence would be an added cost. So where do you want to go? I'm okay to spend a little bit more in embeddings and doing the RAG thing, but I want to get my business right, my customer with the right experience.
Totally, I agree with that. And with that, I'm just going to say thank you, Naresh, so much for your expertise and your time. You can join any other call that you want right now, but thank you for being with us with the Startup School, and big thanks from our audience as well. And to all of you watching us, we just passed the 90 minutes mark, which means this is the end of the Startup School today. All that is left for me is to invite you to Thursday. Same time, February 8th, we're going to build some enterprise chat apps using GenAI with two instructors this time, Alessia and Javier. So I hope I'll see all of you on our next GenAI session. This was Timon with Naresh. I wish you all a great day, great evening, and see you in 2 days.